register set to our left. So let's now put the correct addresses in memory. Maybe make it even, highlight it even more by moving these addresses, because basically in the program we're going to show you the data is below the actual instructions. So here's the data then, and what this instruction does, let's have a close look at it then. It says load register 1. So register 1 is here, and it says load it with the data at location in memory AVAR. So inside there we'll actually have the address of that. So the address of that is mapped to 1C, and that will be the address of AVAR. So that instruction then means that we take a copy, and only a copy, we don't move it, of the data AVAR, which is this entity, and move it into the register. Okay, we've processed our first instruction, and we've seen our ARM Komodo simulator on paper will enable us to visualize data processing and algorithmics. So this is normally done by instructions, as we've seen, and it moves the data from the location it is in memory, as we've seen, to a location to the correct register in the register set. So once it's done that now, we can move on to the next instruction. So what we're talking about here then is a sequence of steps. Well, let's go through them then to understand what the steps are for running a program with this ARM on paper simulator. The first thing we do is we load in the program. So let's go back to the start again and say up here we'll have a compile and load button, which we see on the simulator, but I'm not showing it in this on paper version. So on your real Komodo simulator you will load the program and compile it and hopefully remove any errors, and then load it into the simulator. So when you do that, it will appear in the top window like so, and also a numerical representation of it will appear in the bottom window. So then you execute each instruction in the program sequentially. So what actually happens here, and we'll just show you where the data is because the data is below the program. So if you can understand that the memory sequence is down and then underneath it is the data. These are the addresses of the data, and this is the data, which is AVAR, BVAR, CVAR and SUM in locations 1C, 20, 24 and 28 hex. So let's say that that's what it does. So what does it do next? Well, it moves the data in memory to the specified registers in the CPU, and that's the way it processes data. And then when it finishes its processing the data in the register set, it moves the resultant back to memory. Okay, let's do that then. So in this case, let's start with instruction 1, and it says load into register 1 AVAR. So it loads the data and takes a copy of AVAR, which is at address 1C, and moves it into register 1. And then the next instruction, this instruction, says load register 2 with AVAR, and BVAR is at address location 20. So we load and take a copy of that memory location and move it into register 2. Now the next thing it does is it moves it performs an add. So now we take those two numbers in R1 and R2 as it says here. Let's have a look at the instruction. And this instruction broken down basically says add R1 to R2 and then place the result in R3. So I'm just going to reuse this 3 for a minute. So basically what it does, it adds R1 to R2 through an accumulator, and the result is 3, and that 3 is placed in R3. Then it goes to the next instruction here, load R4 with CVAR, and CVAR is actually 3 as well, so it then loads 3 into R4, and then it says add R5 is the resulted accumulation, and we're adding R3 and R4. So I haven't actually performed this correctly. I need 2 3s, but let's just imagine we've got R3 has a 3 in it and R4 has a 3 in it. We add those and the result goes into R5, which will be 6, and then 6, as we see after this add instruction here, is then stored, and R5, a copy is taken and placed in the sum here. So this 6, which is virtual in our model, I must admit, sorry about that, is now placed here. So that's given you a view of how data is processed. So let's just go over that again. What happens is we store the data in memory, and then we move it to the register set. And we move only those registers that are required on an instruction by instruction basis. And then once we finish the processing, we move the data back from the registers to the memory. So really this is a cycle of memories to register, or the required memory variables that are stored there are moved to the registers. Then we process it, and then we move it back to the memories. So now we've got the concept of how a ARM simulator or a real computer really works. So as we can see, the registers are represented here as a sequence of R0 to R6. So that's how you'll view them in your physical ARM simulator Komodo when you do your labs. And again, we can use the registers to store information and process information. So can we now answer this question, what do they show us, these windows? Well, let's go over it again. So this implementation on paper of a Komodo simulator shows us where the program's loaded. It also shows us on an instruction by instruction basis which memory location it's loaded into. As well as doing that, and that's in the program window, the numerical representation of the program is loaded into the memory window below. So it shows us on a location by location basis the numeric representation of these human understandable instructions above in the program window. So now we can see where each of these is stored and how the data is then moved from the memory into the registers and processed. So first we see that it's important to understand a load operation. The load loads the program physically into our simulator, into the top window, the program window, which is human understandable so we can read it, and the bottom window, which is numeric, which shows us how it's actually, even through a computer, visually loaded in as numeric data. Then we can actually step through the instructions and move the data from the memory to the registers and back again. So this is quite empowering, and the program you've just seen is in one of your first lectures that you should have seen, which basically shows you how to add 3 numbers together, accumulate 2 of them, accumulate that sub-accumulation, and then save the result. So hopefully this tutorial has explained some very basic facts about the Komodo simulator, which is, it's basically made up of 3 windows. These windows are the program view, where you see the algorithmics on an instruction by instruction basis, and they're loaded into particular addresses. To see the numeric representation of this, we look below that window and you see the memory window. And again, they're loaded into sequences of specific memory locations with specific addresses. Then when the data is processed, it's moved from specific memory locations into specific registers, and then particular registers, say this R2 and R3 are added, the resultant is then placed in, say, R4, and that result in R4 is then placed back in memory. So that's the basics of our Komodo on paper simulator, which hopefully shows you how Komodo works and gives you insight into how programs run, and this is how they actually run on a real machine too. Thank you for watching this tutorial.